All right. Today we're going to talk about the law of cosines, which is going to allow us to solve for the other two types of triangles. So that's when we have either side, side, side. So we're given the three sides of the triangle, but no angles, or side, angle, side. We're given two adjacent sides and the included angle. So in both of those cases, you wouldn't be able to use law of sines because any equation you set up with law of sines would have multiple variables. All right. So here's our law of cosines in three forms. Let's just focus on the top, the first line. All of these are just basically if we rotate the triangle onto a different base, it'll shift the variables around. But something you should notice about this is it kind of looks like Pythagorean theorem, right? So a squared equals b squared plus c squared minus 2bc cosine a. This is an equivalent equation where they've isolated the cosine. And so we would use this form. It's called the alternative form when we're trying to solve for an angle rather than a side. Okay. All right. I'm not going to take the time to prove this like we did with law of sines, but if you're interested, you can just pause it on this slide and it goes through a step-by-step proof. It basically is about putting an oblique triangle into the coordinate plane and drawing in a height, and then just basically using right triangle trig and the Pythag theorem to establish this final relationship. All right, so let's see how we can use the law of cosines. You're going to want a calculator out for this. Let's walk through an example here. So this is the side, side, side case. First thing we're going to want to do in the side, side, side case is solve for the biggest angle. And remember that in triangles, the opposite side corresponds to the size of the angle. So the biggest side will have the biggest opposite angle. So I'm going to solve for the biggest angle first, which is B. And we're going to use the alternative form because we're solving for an angle. So cosine B equals, and let's just go back to our formulas. That'd be the second one, right? So a squared plus c squared minus b squared. A squared plus c squared minus b squared over 2ac. All right. And so now we're just going to plug in all the information that we know and solve for what we don't. So we know all the sides, we don't know the angle. So a squared is 8 squared plus 14 squared minus 19 squared. That's all over 2 times 8 times 14. All right. And then the idea is going to be that we need to isolate B. So to do that, we are going to take inverse cosine. So inverse cosine of 8 squared plus 14 squared minus 19 squared over 2 times 8 times 14. And if we're careful, we can just go ahead and pop that whole thing into the calculator as it is. You just need to make use of parentheses the way I've written them out here. So let's go to our calculator. So we're going to do inverse cosine. I'm going to do parentheses 8 squared plus 14 squared minus 19 squared. Let me just verify that that's correct. Yeah. Over 2 times 8 times 14. So divided by, and I want to put the denominator in its own set of parentheses as well. So 2 times 8 times 14. All right, that should do it. And we're getting about, I'm going to round this to the nearest degree, so 117 degrees. All right, so for angle B, we're getting 117 degrees. Okay, now I want to solve for angle C and angle A. Now that we have angle B, we can revert to using law of sines. I'm going to go ahead and solve for angle A. You could solve for angle C. It doesn't matter at this point, but I'm going to say sine A over side A, so over 8 equals sine B, so sine 117 over 19. And we'll go ahead and solve for A. So isolating sine A, 8 times sine 117 over 19. And then again, use inverse sine in this case. So inverse sine of 8 times sine 117 over 19. And that is multiplication. I don't want you to get confused. I kind of wrote it like it's subtraction, but that's times. Okay, let's pop that in the calculator. So inverse sine 8 times times sine 117 divided by 19. All right, we'll round that to the nearest degree, so 22 degrees for angle A. And then finally, angle C. Since now we know 2 of the 3 angles, we can just add those and subtract from 180. So 180 minus 117 plus 22. All right, so that comes out to 41. Now we have our solved triangle. All right. So in the side case, start by solving for the largest angle, then revert to law of sines for the second angle. Then you can just use the fact that all 3 angles add up to 180 degrees. All right, let's do a second example. So this is going to be a side angle side example. All right, so in this case, first thing we want to do is solve for side A. So we're going to use this form of our law of cosines. So A squared equals B squared plus C squared minus 2BC cosine A. So since A squared is our unknown, we can fill in B squared and C squared. So that's 9 squared plus 12 squared minus 2 times 9 times 12. And then it'll be cosine of that included angle, so cosine 25. And then, of course, we take the square root to isolate A. So A equals root 9 squared plus 12 squared minus 2 times 9 times 12 cosine 25. Now, normally I say when you introduce a square root to solve, you're going to get plus or minus. In this case, since A is representing the side length in a triangle, we only care about the positive root. All right, so we'll pop that whole thing into the calculator. So square root 9 squared plus 12 squared minus 2 times 9 times 12 times cosine of 25. And we go ahead and we get 5.4. So I'm just going to do this to the nearest tenth. So this is 5.4. So this side is 5.4 meters. All right. So now we need to solve for the other 2 angles. but we have enough information to use law of sines to solve for one of the angles. So I'll solve for angle B first. So we'll say sine B over side B, so over 9 equals sine of angle A, which is 25 degrees, over side A, which is 5.4. Just multiply by 9. Sine B equals 9 times sine 25 over 5.4. And then take inverse sine to isolate B. 9 times sine 25 over 5.4. And then we'll pop that into the calculator. So we got inverse sine. Oh, didn't mean to do that. So inverse sine of 9 times sine 25 divided by 5.4. All right, I'm going to round this to the nearest degree, so 45 degrees. Oops. 45 degrees for angle B, and then again to solve for C, now that we know two of the angles, we can solve for the third. So C is just 180 minus 45 plus 25, which would be, what, 70? So C is 110 degrees. Okay. And so again, we have our solution to the triangle using law of cosines for the side angle side. All right, let's see a few applications. So we know that the pitcher's mound on a women's softball field is 43 feet from home plate, and the distance between the bases is 60 feet, as we can see in this figure. In softball, the pitcher's mound is not halfway between home plate and second base. And so I want to know, how far is the pitcher's mound from first base? So I'm trying to solve for H here. So we're trying to solve for a side. So we're going to use the kind of original format of the law of cosines rather than the alternate format that we use when we're trying to solve for a side. All right, so I'm trying to solve for h, so I want to use the form of h squared equals, now in this case, it would be f squared plus p squared minus 2fp cosine of the angle between f and p, which is angle h, right? So when I plug in the values we're given, this is h squared equals 43 squared plus 60 squared minus 2 times 43 times 60 cosine 45. Okay, take the square root of that whole deal. So root 43 squared plus 60 squared minus 2 times 43 times 60 cosine 45. And we'll head to the calculator. So this whole thing can go in square root 43 squared plus 60 squared minus 2 times 43 times 60 cosine 45. And there we go. We get 42.43 feet. You can see it's almost an isosceles right triangle, but slightly off from that. Okay, let's do another application one. So in this example, we're given that a ship travels due north and then adjusts its course as shown in this figure. So it takes kind of a slight left at point B. And after traveling 80 miles in its new direction, the ship is 139 miles from the point of departure, and describe its bearing from point B to point C. So really what we're looking for here is we're looking for kind of this angle, right? So to find the angle between those two right here, first we're going to solve for angle B. And in this case, you can see we have a very oblique, very obtuse rather, triangle. And we're given all three sides. So it's law of cosines, and we want to solve for angle B. So the form we're going to use is that, here we go, cosine of angle B. We can go back and look at our formulas. So cosine of angle B, so the second one again, is a squared plus c squared minus b squared over 2ac. So a squared plus c squared minus b squared over 2ac. All right, so cosine of b is a is 80 and c is 60, so 80 squared plus 60 squared minus b is 139 miles squared over 2 times 80 times 60. All right, then we want to isolate b, so we're going to take inverse cosine of that whole mess. So inverse cosine, and we can, again, enter this just as is in the calculator as long as we're careful with our use of parentheses. So we're going to want to enter it like I'm writing it. All right, but just like that. So inverse cosine of the square root, oh no, not the square, I'm sorry, inverse cosine of parentheses 80 squared plus 60 squared minus 139 squared, close parentheses, divided by open parentheses 2 times 80 times 60. All right, and I get 166.14. And that would be degrees. So our angle B right here, this angle is 166.14. And notice that that angle, that green angle, make a straight line, so they are supplementary. So to find that green angle, I can just say 180 minus 166.14. And that's going to come out to 13.86. So the angle we're looking for is this, and that's 13.86. And just remember with bearings, they're kind of written backwards. So that is west of north, right? And the way we would write our final answer is that it is, the boat is traveling 13.86 degrees. And then we put the west after and the north before. So that means 13.86 degrees west of north. Okay. All right, just one more. Just like the law of sines produces an area formula, the law of cosines also produces an area formula. It's named Heron's formula, after Heron of Alexandria around 10 AD. And it's just this, root S times S minus A times S minus B times S minus C gives us the area of the triangle, where S is the sum of all sides divided by 2. And so in this case, if you know all three sides of the triangle, you can use that information without having to explicitly find the height. So use Heron's area formula to find the area of the triangle with side lengths. A 43 meters, B 53 meters, and C 72 meters. So just going to sketch myself a triangle. All this is angle A, angle B, angle C. So this will be 43 meters, 53 meters, and 72 meters. So again, Heron's area formula is area is the square root of S times S minus A times S minus B times S minus C. And really the first thing we want to do is compute S. So S is the sum of all three sides. So 53 plus 43 plus 72. Now we're going to divide that by 2. 53 plus 43 plus 73. Divide that by 2. There we go, 84.5. All right, so my area is root 84.5 times 84.5 minus 43 times 84.5, sorry, minus 53 times 84.5 minus 73. And I'm just going to pop it in to the calculator like that. Whoops. So square root 84.5 times 84.5 minus 43 times 84.5 minus 53 times 84.5 minus 73. All right, 1127.08. And our units were meters, so the area would be square meters. Okay. That's it. Law of cosines. That's our boy Heron of Alexandria. Don't forget to smash like and subscribe and get started on your group work in the delta math.